Good morning. My name is Jayantha, Obeysekera, better known to my friends as Obey. I'm the director of the Sea Level Solution Center at the Florida International University. I'm a registered civil engineer with background in water resources, climate change, and sea level rise. I would like to recognize my colleagues in the leadership of the Sea Level Solution Center, Dr. Tiffany Troxler and Professor Mike Sukov. Tiffany is the Director of Science and has expertise in ecology, adaptation using natural infrastructure, and sea level rise. Mike is a hydrogeologist with expertise in groundwater modeling and sea level rise implications. I'm pleased to provide this short presentation covering the topics suggested by the organizers. Our center is housed in the Institute of Environment, one of few preeminent programs at FIU. As you will see, we collaborate with local, regional, national, and international groups. Our mission includes not only science research on sea level rise and climate change in general, but also assistance to local government, to cities such as Miami Beach, the city of Miami, and also the regional governments such as the South Florida Water Management District. One of the key success stories in our program is the close collaboration with the non-governmental organizations in the region. Our team is much larger with over 60 faculty from other colleges in FIU, including arts and science, engineering, business, communication, architecture, hospitality, and public affairs. We are an active member of the Florida Climate Institute, otherwise known as FCI, a consortium of universities. I'm the statewide co-director of FCI. I would like to use this slide with lots of pictures to illustrate the complexity of the region and how environmental stresses pose future challenges. As the graphic in the middle of this slide illustrates, highly urbanized coastal areas of South Florida is already facing increasing frequency of flooding due to combination of high tide with or without storm surge and extreme rainfall. Saltwater intrusion due to highly permeable limestone aquifer threatening freshwater well fields and failing on-site septic systems due to rising water table. Sea level rise also impacts the Everglades ecosystem. The regional resiliency partners need to know how the science should be used for developing adaptation strategies. To support these efforts, we focus on prediction of tidal and compound flooding, understanding land-ocean interaction, prediction of extreme precipitation, smart and connected water quality monitoring, regional sea level rise projections, how non-stationarity may be used for planning purposes, and recently, the cascading impacts and economic assessment of hazards. Citizen science program is a major component in our center. So who are our stakeholders? The Southeast Regional Climate Compact, or simply Compact, is a unique entity covering the entire Southeast Florida region. It's a partner. We have assisted the compact in the development of the Unified Sea Level Rise Projections, which is a standard that all the stakeholders are expected to use. Now we are assisting the compact in the development of climate indicator toolkit for the region. We also work with the South Florida Water Management to develop rainfall and sea level rise scenarios for regional water management planning. We collaborate with several nonprofit, non-governmental organizations, and they include Miami Foundation, Catalyst Miami, Van Allen Institute, and the Clio Institute. They are very active in the region. Numerous cities and counties are also our partners. At the state level, we have partnered with the Florida Building Commission and the Florida Department of Transportation. The focus here is how to change the design and planning practices to account for sea level rise and climate change in general. We strongly emphasize citizen science for two reasons. First, for educating the general public, particularly the younger generation. And second, to collect extensive data which otherwise is not feasible currently. We have organized what we call the annual Sea Level Solutions Day, typically coinciding with the king tide flooding in the southeast region. You see a picture of the citizen engagement during one of those events. We partner again with the local NGOs, cities, and the county governments in this effort. This has been going on since 2016 and has allowed us to collect valuable information on flooding along with photographs for quality control. Using this data, we are now trying to develop recurrent flooding metrics for various neighborhoods in the region. We are also expanding this into citizen monitoring of extreme heat in urbanized areas. Continuing with the theme of citizen science and supporting tools, we have developed a flood reporting app, you can see on the left-hand side, using which participants can report water depth and salinity and submit photographs. A popular tool developed by the communication department at FIU is what is known as the ice on the rise, you see in the middle, which is a tool the public can use to obtain information on sea level rise projections and implications and view flood reports. Another unique tool is the 3D printed refractometer adapter for taking timestamp pictures of the salinity measurements. We have started coupling citizen science event with drone surveillance. This slide shows a king tide event during which we had a drone flyover in the flooded area of Showcrest neighborhood in Miami to supplement the data collected on the ground. And this area floods quite a lot during king tides. The data will be useful for making more accurate predictions of local flooding extents, and we believe this technology will be used more regularly and routinely in the future. The link to the video is available on the slide. In another project, we have partnered with the city of Coral Gables to install instrumentation for monitoring tidal elevations and water quality in real time. The city uses this data to determine bridge clearance for residential boat use. The equipment has an off-the-shelf near real-time data interface for the public, and it is almost complete at this time. So what are the highlights of our success stories? Modeling of sea level rise and groundwater to advise the Florida Building Commission to modify the Florida Building Code to account for sea level rise is one of our major recent projects. See on the upper right-hand corner showing future groundwater levels in response to sea level rise and depth to water table, which is important for predicting flood hazards. We also conducted a workshop to develop unified rainfall scenarios for Florida. You see the team that was assembled across the nation to discuss how rainfall scenarios could be developed. We also have a national level research projects we partner with. One is the Urban Resilience to Extreme Sustainability Research Network, and the second is the Urban Water Innovation Network. We also investigate the effect of projected sea level rise on the Everglades coastal ecosystem. You see a picture of the Everglades in the middle. And also, finally, we provided leadership to develop unified sea level rise projections for the region, and more importantly, the guidance on how to use these scenarios for planning. You see the notice on the slide, the graphic, the projects that they could use a particular scenario in the projections set that we have provided. Here we present ongoing activities and future directions. Through a couple of NOAA-funded research projects, jointly with Deltares in the Netherlands, we are expanding our scopes of assessment. First, we use a tool known as Circle. You see it on the upper left. to look at cascading effects of hazards on infrastructure such as roads, energy facilities, ports, airports, water and wastewater systems. And for this purpose, we have engaged the stakeholders to provide these connections. Second, we have been promoting the concept of dynamic adaptive policy pathways to determine phasing of adaptation solutions with a focus on both data and tipping points. Here you see an example of such a pathway map using what is known as a metro map. We are also hosting a workshop funded by the Coastline and People program at the NSF to assess the interoperability of systems and models, and also to develop what we call a coastal observatory. Other areas of research are the prediction of future extreme rainfall and localized recurrent flooding. So what are our challenges and gaps? In terms of challenges, I would say integration of systems, including physical, social, and economic subsystems, interoperability of these systems and models, and compounding hazards, and multi-sensor observation platforms such as drones, autonomous vehicles, and remote sensing are all challenges. Of course, finding good students and postdocs in this environment and funding is always a challenge. So what are our gaps? I believe social, behavioral modeling and data collections for hazards are a big gap, and also the econometric modeling of these systems. You see my email address here and our website. I appreciate you listening to my talk, and thank you.